Hey guys, we're starting off Unit 4 with systems of equations. Now you've seen systems of equations before in 8th grade where you've seen normally two equations on a graph and you had to find that point of intersection, also known as a solution. So we're going to look at systems of equations today in this first lesson, and we're going to be able to see if we can graph them, which is different than what you have done in the past, and then be able to identify the solution, which you've seen before. So just some quick vocabulary terms. A system of equations is a set of two or more equations or functions on the same graph. So for this, think of you have the same variables, x and y, but maybe you have two people that you're comparing, or two companies you're comparing, or two different situations, but the variables, the x and the y, are going to be the same. And then a solution to a system of equations is the point of intersection between those two or more equations. You could have more than one solution. You could have no solutions, you could have one solution, or you could have infinite solutions if the equations happen to be the same line, right? If both situations are the same. So that solution to a system of equations is just where the x and the y coordinate are the same for all of the graphs. Okay. And there you have the notes written down for you. That point of intersection, we would always write a solution as x comma y if there is truly one point. But like I said, the options for a solution are: you could have none solutions or no solutions. You could have one, or you could have infinite in these cases with linear equations. Okay, those are your options. So looking at the three graphs below, the question says, what do you notice about the solutions to each of the systems of equations above? So let's look at them. Well, this first graph, I have two lines. I have a red line and a blue line. And I noticed that they don't ever cross. Okay, because they don't cross, they're actually parallel lines. Okay, and the way that I want to answer this question is I'm just going to kind of section off, I'm going to talk about each of them here. So this is parallel lines. Oops. They don't ever cross. They have no intersection, so no solution. Right. And just a little side note that when you have parallel lines, the slopes for both of these lines will be the same. Okay. Parallel lines means same slope. Okay. Maybe make a note of that. We'll talk more about that later. This second one, I see that there is a point of intersection, right? And that point of intersection is going to be our solution, whatever the coordinates are for that point. So I'm going to make a point at that, and then I'm going to say, okay, that is -2, 1. Okay. So what I've noticed is that I have one solution here. And that one solution is at -2, 1. Okay, so that answer would be -2, 1 is my solution. And then this last one here, I noticed that both of my lines, they're purple, and it has two different errors, so I have two lines that are fully on top of each other. Okay, so these lines also have the same slope, but they have different the same y-intercept, right? They're basically on the same line. This would be when we would get our infinite solutions, because there is literally a solution at every possible point. And one more little tidbit we can make about the middle graph is those lines are perpendicular, and those also have a relationship between this slope. And we're going to get into more of that later, but maybe you could figure it out as you move about this and you notice you have perpendicular lines. So let's look at some examples. Okay. Now remember, the two things that we said we want to be able to do are to graph systems of equations. Okay, and then also find these solutions. So we just looked at the types of solutions that we can find. Now, graphing them. We graph two equations. That's all we need to do. So if we know how to graph equations in y equals mx plus b, then we are good to go. So below here, I have two equations. I have an f of x, and then I have a g of x. Remember, that's just how we separate that I'm looking at one equation and then another one. And I'm going to do these two in each equation in a different color. That way I can identify which one I'm looking at, okay? So I'm going to do my f of x in this light purple, and then the g of x, I'm going to do it in this darker purple. So I'm going to graph f of x first. My slope and my y-intercept, I'm just going to identify here. That way I am rewriting to help make sure I understand. My slope is negative 1/3 and my b value is 1. So first thing I do is start with my y-intercept. I'm going to plot a point at 1. And then I'm going to use my slope and go down 1 and to the right 3. Okay, in order to make my line. So there we have our first one, and you might have noticed I think I made a mistake when I was plotting that point. I should have gone just down 1. I think I went down 2, but I fixed it. Okay, I went either up 1 and to the left 3 or down 1 to the right 3, and I've labeled it f of x. Okay, now I need to do my second line, g of x, which has a slope of 2 and a y-intercept, a b value of negative 6. So I'm going to start by plotting my y-intercept and then using my slope of positive 2 to draw my second line. So now that I have both of my equations graphed, okay, I've checked them to make sure that I use the right slope and the correct y-intercept. Now I'm going to see if there is a solution. I notice that these lines do intersect, and they intersect right here at this point. I'm going to do in blue. Okay, this is where they intersect. And that is at the point 1, 2, 3, 0. So my solution to this system of equations is going to be at the point 3, 0. All right, let's look at example number 2. I'm going to do the same thing. I'm going to make sure I know that my f of x is going to be in the light purple, and then in the dark purple is going to be my g of x. It doesn't matter which one is which, or if you even do different colors. I just like doing it in different so I can separate and make sure I'm understanding. Okay, if you do them both in pencil, that's fine as well. I'm doing this more just to help you identify the equations as we go. So f of x, let's do that one first. That slope is negative 3/2, and that y-intercept is 2. Some things I'm noticing, I've noticed a lot, is that people are forgetting that to check whether or not the slope is negative or positive, and graphing them all as positive, or just not realizing what it is. So make sure you realize that that is a negative slope there. It said negative 3/2, right? There is a negative sign right there, okay? And then in my second one, my slope is 1/4, and my y-intercept is negative 5. So I'm going to graph both of these. Go ahead and graph them and check your work in just a second. Okay, so now I've graphed both my f of x and my g of x. Those should look like that. I need to see if there is a point of intersection, and I find that there is right here at this point. That point is at 4, negative 4. Remember, the x value always comes first and the y comes second. So my solution is 4, negative 4. All right, let your teacher know if you have any questions.